All right, we're going to go ahead and get started here. Sorry for the late start. We had a bit of a late transition going here. But let's get going then. All right, so I'm going to talk about adding a new storage provider to Rook and what that looks like and some of the implications of that. My name is Jared Watts. I am a Rook senior maintainer, and I'm also one of the founding engineers at Upbound. So we are going to jump in here. Now, this is, I think this is the very last session of the very last day of this conference, so it's always good to see anybody who sticks around for that. I saw one of my really good, a guy that I used to work with at the last job. I really like him, and I thought he really liked me, but I told him that I was presenting at 4:30 today. He's like, oh, yeah, I'll catch it on YouTube. So you guys are here. I know who my real friends are now. All right, so I've spoken about Rook already this week. I did the introduction to the Rook project a couple days ago, and Travis Nielsen, one of the other maintainers on the Rook project, spoke about Rook earlier today, and we had a little session at the CNCF's Meet the Maintainers booth earlier today too. So there's been a whole lot of Rook, and I'm sure a lot of you have already heard about it, but we're just going to do a little bit of level setting here so we're all on the same page. So what is Rook? So Rook is a cloud-native storage orchestrator. And what that means is that we've taken Kubernetes, we've extended it with some custom types, custom controllers, and those are specifically geared towards storage and how to manage storage. So it's there's some automation and software logic around deploying, bootstrapping, configuring, scaling, migrating, disaster recovery, all sorts of stuff for complicated distributed storage systems, bringing them into Kubernetes and helping them run well there. So Rook is also, it's got a framework now for adding or integrating other storage solutions into Kubernetes as well. And that's going to really be the focus of this talk today and what that looks like. And the Rook project, it's open source with the Apache 2.0 license, and it is hosted and donated it to the Cloud Native Computing Foundation. We did that at the beginning of this year, so that was January, and at the sandbox level. And just back in, I think it was September or August, we were graduated to the incubation level. All right, so let's talk about some of the challenges running storage. So really what you've seen for a while with Kubernetes, there's this reliance on external storage or storage solutions or systems that are outside of your cluster. So that requires that those systems are created, managed, accessible. There's a burden associated with those, right? Somebody's got to do that for you. And then you can also take advantage of cloud provider managed services. Like if you need block storage, you can use Amazon's EBS or Google Persistent Disk. And those services are great. They come with an SLA. They come with a full team that's managing it for you. So they're good. But if you take some of those services that they have, you can get yourself into a situation with that dependency on that service and making it difficult to move somewhere else. And you get stuck with that vendor lock-in. Another problem is with storage is day two, right? There was a whole talk on this that it was a panel that I moderated on Monday at the Cloud Native Storage Day, where day one is cool. You get your storage all set up, it's running, everything looks like it's working good. But then you've got day 2, 3, 4 where all sorts of disaster can happen. So somebody's got to manage your storage for you. So let's talk about a couple of solutions for those. One of them is that Kubernetes is pretty good at managing the lifecycle of complicated software solutions. So maybe we can bring our storage systems inside of Kubernetes and harness that power of Kubernetes to manage some of these components for us. So with some smarts and automation that we can put into software, maybe we can do some of that operations, day 2 operations stuff for you, that deployment burden for you. Let's let software do it. That's a lot easier. Another thing to deal with that vendor lock-in problem we're talking about is, maybe we should create some portable abstractions for all of our storage needs, not just block and file. And so let's talk about why that specifically is important. So the power of portability, for me, that comes down to the power of choice, actually. So if you take your application and it's truly portable, that all of its dependencies, all of the resource requirements, everything that application needs to run, if you can take those and run them anywhere, then now you have choice, right? You can choose to run in one cloud provider because it's the cheapest cost, or you can choose to run in another cloud provider or on premises because of other things like feature, geographic presence, availability, durability, compliance, all sorts of stuff. But the point is, you have a choice. And so what does it look like to start taking our data wherever Kubernetes goes? So Kubernetes, you say, portability, and a lot of people think so far as Kubernetes has done a great job at that, which it absolutely has. But that's for pods and volumes, right? So you can abstract an application to a pod, and it's containers that are going to run in a pod, and its data needs for a volume. Those are very good abstractions. They go a long way. But there's some things that your application might need to use that don't fit into those categories. What about message queues or object storage, databases, data pipelines, all sorts of other things that we don't have good abstractions for right now. And that makes our applications very difficult to be portable. You can't just take a dependency on some of Amazon services and then just move to Google very easily. You have the bit of that gravity there. So there's also a new project, a new open source project that is just over a week old now. We open sourced it last week, so it's still very new, and it's called Crossplane. And together with Crossplane working together with Rook, we can start solving some of these problems about having portable applications that can run anywhere in the cloud and also on premises as well. And that's going to be the demo we're going to look at later on today. All right, so let's talk about a few of the foundational knowledge that we need to start talking about how do you add a storage provider to Rook and what does that look like. So we talked through this in a couple of other talks, and people are starting to, CRD is becoming a pretty common expression now, so we won't spend too much time on it. But basically with a custom resource definition, you can teach Kubernetes about new types. You can declare your own custom types, and they become first-class citizens in the Kubernetes experience too. So just like pods and config maps and secrets and such, your arbitrary custom types can start being displayed and used and manipulated within the Kubernetes API and kube control, just like any other of the first-class or built-in objects, excuse me. And now operators as well. So operators are a very useful software pattern that we found. And we're starting to see those pop up all over the place to manage complicated software solutions. So the first time I heard about this pattern, I think was from CoreOS a couple years ago. I think that they had a blog post that really defined what this operator pattern is. And so, what it allows you to do is it allows a user to define their desired state of what you want the application to do. And then the operator looks at that desired state and takes care of everything else for you. So it does that in 3 steps. One of them is it's first got to know what this system is doing in reality. It's got to observe the system, see what's there, analyze what the difference between what the user has asked for, their desired state, and what the actual system is doing. Make a comparison there and figure out what to do, what to act, what operations to perform to drive that system towards what the user's desired state actually is. So there's a couple different ways to write operators. What Rook is currently doing in the Rook project, we actually have our own Rook operator kit. And this was written, I think a couple years ago almost. And it was, a first attempt at providing a framework to make it easier to write these operators, these custom software to manage other software inside of Kubernetes. And so that allows you to register your custom resources, get events about when a user creates one or deletes one or updates one, and start running code in response to that. But there's been other projects that have come out that are also solving this problem. And one of them is the Operator SDK that came out of CoreOS. and KubeBuilder is one that we've been using as well. But these take that idea a little bit further and provide a lot of generated code for you and basically takes the job as a developer of writing an operator and takes away some of that manual work and makes it easier for you to write reliable operators to manage other software systems. So we'll see a little bit of examples from a couple of those, actually. All right, so back to Rook. So as we said before, you can think of Rook as a framework for managing other storage systems and deploying them, configuring them, bootstrapping them, all that sort of stuff, and making that job easier. So this framework here that allows storage systems to do that, there's a couple different facets or areas that it enables to make that job easier. So one of them is that it provides a storage resource normalization. So what that means is that it provides a common language or common way to describe how or what storage resources in your cluster should be included in the storage system. Like, for example, this node and not that node, nodes with this label, selectors, specific devices, SDA on node 4, whatever it may be. It provides a common way to describe that and then create a storage fabric out of those. And it's kind of like we were talking about with the operator frameworks. It does all the patterns and plumbing to get an operator up and running, start talking to the Kubernetes API server, and perform its duties, and start focusing then on how to manage the specifics and business logic of specific storage systems. And policies and specs and logic, reusable stuff that kind of helps and makes it easier for storage systems to do their job and make sure that their storage is performing well inside of Kubernetes. And we also have, in the Rook project, integration pipeline that will, test all your storage systems and the code on a whole matrix of Kubernetes deployments and cloud providers and such. So it makes, it makes the job of, if you want to bring your storage into Kubernetes, it makes, gives you a whole bunch of different features and functionality to make that easier for you. So we started with just Ceph at the beginning of the project, and then we added on CockroachDB and Minio in the Copenhagen KubeCon timeframe. I noticed that I started measuring when things happen, both in software projects and in my life, by when certain KubeCons were. So they're kind of milestones that you can think. I don't know what release that was for Rook, but I know what KubeCon it was. And then we've also, in the release that we just did last week, so I know that one, that was 0.9 for KubeCon Seattle. And we added NFS, Cassandra, and Nexenta EdgeFS too. And so the interesting thing that I really wanted to call out here is that this is a community-driven project. The first couple of storage systems we were supporting, especially Ceph, that was done by the core contributors of the Rook project. But with this framework now, we've enabled a whole bunch of new contributors to start adding more storage into Rook and into Kubernetes there, as well. The storage teams themselves, the ones that are the experts on those storage systems and know how to run them best, we've enabled them to start writing some of this code to bring them into Kubernetes. So I wanted to call specifically Yanis Zarkadas. He works at Arcto, and he lives in Greece, and he did single-handedly the Apache Cassandra operator. And the amount of functionality that he put into that before it even got into master branch was impeccable. So that guy is amazing. He did a great job. Rohan Gupta he was a Google Summer of Code mentee for us. So through that project there, he got to work on enabling network file system storage in Rook. And then the whole Nexenta team, they have been enabled through the Rook framework to bring in their EdgeFS file system project, or storage solution. All right, so let's start looking at a little bit of code here. And then we're going to get into a demo. And I will not go over time, I promise you. So you can get out of here and go to your holiday parties or whatever you need to do. So this right here is a custom resource definition. This is what tells Kubernetes that you have a new type. This is a type that represents object storage in Minio. And it gives it the name and some of this metadata that you can then, that's necessary to start manipulating it and showing up in kube control and all sorts of stuff. So the API server will know what a Minio object store is after you create this custom resource definition. Now this is an example of creating an instance of that object storage type that we just declared. So this is a very contrived, or very simple example where we're basically saying, please give me an object store created by Minio and give me, spread it across 4 nodes. So very simple, but this is a way you can use kube control, the native Kubernetes experience, the Kubernetes API to start creating new types of storage inside your cluster. So this is sort of what the experience looks like. We did a kube control create on that object store YAML, and then we can say, give me the CRDs, and these are the types that the API server knows about. It knows what Minio is. We can create the actual instance of that object store and do a kube control get, and we can see that object store come back. So the API server knows exactly what it is. That means that our operators will be able to see that somebody has asked for a new instance of Minio object storage, and it can start working on it. So let's take a little bit more of a look on what some more of the complicated specs look like. We looked at a very contrived example at first. But so right here, this is how you start declaring a little bit more configuration about your storage system. What's the important things that that the operator would need to know in order to make that storage system the way that you want it to happen? So we can see here in the red box there that all those things that are circled, it's a square. All those things that are squared are the configuration properties that come from that common Rook framework. So the Minio team didn't have to write any of that logic or spec or information configuration stuff. That just comes out of the Rook framework. So all they needed to do was add the part at the bottom about the access keys for accessing the S3 protocol buckets that Minio Object Storage creates. And that's all that they really had to add there. So the Minio operator, so for each one of the storage systems in Rook, you'll write your own operator for it as well that knows, will be looking for events of when the user has decided to create an instance of your type of storage, and then it will start doing that work to turn that request from the user into an actual functioning storage system. So really what we're seeing here is that we're just wrapping this in a deployment, and we're telling it to run the Rook Minio operator. So it's not too much complicated in here, but the point is that you'll be running a specific operator for your specific type of storage. And building that can be pretty easy because normally what ends up happening is that we'll take the upstream container image for that storage system, so from upstream Minio, and we're just going to slap the Rook binary in there, and then that turns it into basically a container image that is an operator that can start working on the storage system. This one's a pretty optimized system because it's the base image is Alpine Linux, so it tends to be really small when you just throw in the Rook, statically compiled Go binary. So it ends up being pretty slim. Okay, so we saw in YAML that you can specify or declare that you want a Minio object storage with this, and this configuration properties. So that's got to be backed up. And if you're going to do anything programmatic, you have to back it up with some code somewhere, right? So this is what the Golang code looks like that defines what a Minio object storage type or custom resource looks like. And so we see here once again that all these types that are in the square there are coming from the common Rook framework. This is how I want the ability to specify what storage to include. I want the ability to specify what resources should be limited and constrained, such as CPU and memory. I want to be able to specify some networking configuration. How should it use the network in the cluster that it's being deployed to? And then outside of that square, we have the little credentials configuration that's specific to Minio. It's not necessarily a common thing across all storage providers that gets added in there so the user can configure that as well. All right, so the Minio operator's got to start doing something useful. So what it needs to do is it's got to set up a watcher that will get us events for adds and updates and deletes when the user wants to manipulate the Minio object storage system. So this, we'll set up some event handlers that go through the Rook's operator kit, and what they do is they'll listen, subscribe to events on the Kubernetes API server, and do that in a smart way with, informers and caches and some of those more advanced concepts that that basically prevent the Kubernetes API server from getting overwhelmed with a bunch of gets. If we were to sit there and say, hey, do you have any changes? Do you have any changes? Do you have any changes over and over again? That would be a dumb use of resources of the Kubernetes API server. So this does this in an intelligent way where it'll get events. It's more of a push model of when somebody's created a object storage CRD with the Kubernetes API server, we'll just get an event. And this kind of gets into a little bit more of those details there of using an informer underneath, an informer in a cache that does it in a smart way, getting information from the API server without excessively doing a bunch of gets. All right, and then we're getting near the end of this Minio example. So, for your operator to handle your storage system, you've got to write a couple of handlers here, like on add, on update, on delete. And so this focuses on when the Minio operator sees that the user has asked you to add Minio object storage to your cluster, it will go through programmatically some of those steps to make that happen. So it will create a headless service, which is a Kubernetes service object. It'll create a stateful set to back up the object storage that Minio is going to span across the multiple nodes that it cares about. And it's going to create a service object that clients will be able to connect to. So this is all done programmatically using the Kubernetes API and the client Go library. And then similarly, we don't have any body of code in here, but on an update, we get the old object and the new object. We can do a diff and see what changes the operator's got to do to make the user's request to actually be a reality and reflected in the cluster. All right, so now some new stuff here that nobody has seen before. I finished these slides in the code and the demo I'm about to give sometime after midnight last night. So it wasn't finished yesterday, it was actually finished today. So this is brand new. But let's talk about dynamic provisioning. So dynamic provisioning, I think it was first introduced in Kubernetes, and I think it was 1.6 maybe. But that really changed the game for how storage is created and consumed inside Kubernetes by applications. So before static provisioning, what you had to do is an administrator would have to manually create persistent volumes and kind of register them in a big pool. And so when an application or a pod needed storage, it would pull one from that pool. When all those persistent volumes that the user had manually created, when you run out, well, you're out of volumes. You got to go manually create more. It involves the administrator, right? And so they came up with this abstraction, this concept of storage classes and persistent claim volumes. And so now I'm going to posit here that pattern is incredibly useful for other types of storage as well, not just volumes. So this can be generalized to abstract types of resources. So we have here in the Crossplane project what we call resource classes and resource claims, very similar to storage classes and persistent volume claims. But this is now something you can use to all sorts of types of resources, databases, message queues, buckets, all sorts of stuff. So a resource class is a blueprint that the admin creates that kind of specifies how storage should be created in an environment. The specific details about it, all sorts of environment details and specifics. A resource claim, though, that's the developer. It's kind of an abstraction of the developer gets to just specify a general need for storage. Just give me a database, please. That's all it's got to say. Very simple. The administrator is taking care of the concerns for you, and the details for you. And this creates a separation of concerns that promotes reusability, reduces complexity, because the developer, all they got to do is worry about their application. They don't have to worry about the specifics of what environment they'll be running in. With dynamic provisioning, when the storage is needed, it's created. The administrator doesn't have to manually create that for you ahead of time. No pre-allocation. And so this gets back to portability that we're talking about. If you can write an app that you don't have to care about the details of how its resources are going to be provided to you at runtime, you can write that app in one way, write it once, run it anywhere. This is true portability. All right, I'm going to get started on the demo, actually, I think, so we can kick that off, and maybe we'll come back to these slides. All right, so this is my cheat sheet here. This is not necessarily meant to be seen, and I'm going to kick this off and to tell you what I'm doing, because this one runs a little bit, because this is doing some cloud operations. Okay. So let's take a look here at some of these concepts I was talking about. So this here, what we're looking at is a workload. This is just a general example. This is not a specific application, but it's conceptual. So what we're looking at here is a workload that's going to run in the cloud and a workload that's going to run locally on premises. Now, they look really similar, right? They're basically line for line the exact same of specifying a resource of Postgres. I need Postgres. Just give me Postgres, please. And then inside the app, being able to extract out that connection information from the Postgres instance about the user, the endpoints. Might have deleted some things I wasn't supposed to, but yeah. So getting the endpoint connection information, user information, password information. But basically, the point is here that your application is written in one way, and it's going to be able to run in any of the cloud providers, Amazon, Google, Azure, DigitalOcean, whatever, and then also run on premises with Rook too. And if we look at the resource claim that I was talking about, they're the same. They're saying a general need for a Postgres database and a specific resource class to use. The one on the left, the one that we want to go to the cloud, is using a resource class that's called Cloud Postgres. And the one on the right that's going to use Rook is called Local Postgres. These are all the same. The user, the application author, doesn't have to know the details about where this Postgres is going to come from. Now this is what the administrator deals with, these resource classes, very similar to storage classes for volumes. Now this is where the details become apparent. And this is a separation of concerns we were talking about, where the administrator has to care about this, but the application author, the developer, does not. So on the left, this is specifying for this Postgres instance, for a Postgres request, I'm going to create that with Cloud SQL in Google's cloud provider. And here's some specific details about it. I want you to use SSDs, 10 gigs each, and the tier of machine to use, some of those specific parameters. And on the right side here, we have a resource class for Postgres inside of a Rook cluster locally. And so what this is doing, tying it back to the Rook storage providers, is this is saying, locally inside Rook, I want you to use CockroachDB. When I say I want a Postgres instance, do it with Cockroach. And use Rook to dynamically provision me a CockroachDB cluster that will serve as Postgres. So our workload, our application, all it said was give me Postgres. That could be CockroachDB locally on premises with Rook, or that could be Cloud SQL in Google, or it could be Amazon RDS, or it could be Azure's Postgres server as well. Doesn't matter. Application doesn't care. OK, so hopefully I gave Cloud SQL enough time to get going. So we created Cloud SQL. Let's look at some of the details of what I did. So what I first did here, and this is some ugly sed, I recognize that, but this was injecting my credentials, my Google service account credentials from a file into a secret, so that when it comes time to provision that Cloud SQL database using Crossplane, it will have my credentials to perform that operation with my account. And then we created that resource class that we had there that says when somebody wants a Postgres instance, use this information to create it with Cloud SQL and Google. And that resource claim that was saying, okay, this is what a Postgres database, which specific class to use in a cloud environment. All right, so that should be running. And let's do the same thing here for Cockroach, for local. So right now, I just created the operator, the CockroachDB operator. This is Rook's, it was written in Rook using the Rook storage provider framework. And it should be running now. So I'm going to say, create the resource class that we says to use Cockroach instead of any other particular specific flavor of Postgres. And now those are things that you would do as an administrator. As an admin of the cluster, you'd be creating the operator and you'd be creating the resource class. And now as a user, I'd be creating that resource claim that is the exact same on both sides of using a resource class for the cloud Postgres and a resource class for local Postgres. All right, so all those hopefully should be running now. So let's go ahead and take a look at what they look like. Oh, wrong one, status. Let's clear some space on the screen. Awesome, so they're all done. So in this command, we're basically saying, please give me, kubecontrol, give me the resource claims for the general need for a Postgres database. And we can see here that general cloud Postgres database exists. It's running version 9.6, and then the local Postgres database is also running here. And now note they're bound. That's the same concept that you see with persistent volumes and persistent volume claims. So what are they bound to? They're bound to the resources that were dynamically provisioned from these resource claims, these resource classes. So we see here, this one is a Cloud SQL instance that's running in Google, and this one is a Cockroach instance that's running locally using Rook on our local cluster. So let's see if, yep, cool. So this is in the Google Cloud console. And we can see here that that database was dynamically provisioned and created inside of the Google Cloud Platform on demand for us as well. And let's take a look, see at the Cockroach instance that's running too. So we should see, I think, 3 different pods running for Cockroach. Yeah, exactly. So in our local cluster, we've got a Cockroach cluster made up of 3 nodes or 3 replicas. All right. So let's hop back to the slides and talk about why this matters. All right. So as we were talking about here, that Rook is a cloud-native storage orchestrator, and it has a framework to allow new types of storage to come inside Kubernetes. Running that storage inside of Kubernetes can be a great idea with operators to make them reliable and do day 2 operations and provide storage right next to your applications that need to consume that storage. And then the thing that's really new here is this concept of dynamically provisioning on the fly new types of storage like databases and message queues, et cetera, in a very abstract and portable way. So that integration between the Rook project here, the new types of storage that Rook's providing, and the new Crossplane project allows you basically to run your applications anywhere and not have to change them at all. And then, that ability there gives us portability, right? The power of choice. So you can start choosing where you want to run your applications based on cost or features or, geographic region, compliance, all that sort of stuff. And we've not been able to do that before. So that's something that is brand new that I think is, Kubernetes did a great job starting with pods and volumes, but we're taking it further now with all sorts of different types of storage with Crossplane and Rook. So if you want to get involved in the projects, Rook.io and Crossplane.io, you can go to those websites. We have GitHubs or open source projects. We're always accepting new contributors. I think the Rook project has over 100 contributors now. So we're really happy about that, but we want to keep it going. Slack, same thing. And Twitter also, talk to us, all that. And I think we have maybe a minute or two for questions, but basically that's it. Thank you very much, guys. I appreciate it. All right. Yeah, I think we have 2 minutes or so if anybody has a question. Yes?
You mentioned you kind of have like a test grid for people making providers that'll run through a good test suite. Could you maybe go in a little on how to, if someone were to start writing a provider, how they would also incorporate into that test suite?
Yeah, so the question was about the integration tests and the test suites, a test framework for new storage providers. So yeah, when we have that set of integration tests, it's running on a public Jenkins server, and when every pull request or every commit to master or the release branches, when in response to that, the Jenkins server will start up and it will start provisioning Kubernetes instances. So it'll do like a Travis is another maintainer here. I think he has a pull request to remove 1.8 and 1.9. But I think right now it's Kubernetes 1.8, 1.9, all the way through 1.13, and on Amazon and Google Cloud as well. So it'll spin those up for you, and then it'll run that full suite of integration tests for all the storage providers on those Kubernetes clusters that it had brought up specifically for those tests. So you can start doing things like create an instance of your operator for your new storage type that you've defined, and then create a custom resource for that operator, so that your operator that Rook has deployed out to those Kubernetes clusters and different versions that we deployed, it'll run that for you and then create your storage from the available resources in those Kubernetes clusters. And then you can write some test cases like, can I find the endpoint and connect to it and create a file or delete a file, and start doing some of those test cases that are specific to your type of storage. But that framework for bringing up Kubernetes, installing your operator, your specific type of storage, and getting it ready for you to start poking with tests is all common stuff. All right, yeah, so that is all the time we have. So thanks, guys. Have a great rest of the week.